This is the quantitative analysis, data analysis. Only thing is with interpretation. As you all know, in the quantitative analysis, there are various techniques. Since I have no idea about the participants very much, I started a very basic analysis with interpretation. Now, I think most of the students or practitioners of statistics, they mostly use the software and try to interpret results. And the basic thing, important thing in statistics is you must understand the concept. If you understand the concept of statistics, it's a very simple subject. I call statistics for life. As you all know, statistics is taught almost all the degrees that show how important statistics is. Now, if I consider concept, in statistics, there are two concepts. One is population and sample. And the related things for the populations are parameters and estimators. Now, these are the population. As you all know, population is the thing where we consider every item in that area. Generally, populations are counted in Sri Lanka once in 10 years, the census. That's a population. Apart from that, very rarely we do populations. However, we want to apply or we want to apply many applications, many decisions to the population. For example, government may want to find out whether for a purpose for some application, they won't know whether the householder's income in Colombo is lower than the householder's income in Gold, something like that. That is a good case example. So something like that, in that case, if you consider population, there are two populations, whole householders in Gold district and whole householders in Colombo district, but that cannot be done. That's called population. So population has we call parameter, for example, in that case, average income of the householders in Colombo district. Therefore, you have to count all the household. That is called the, we call population mean or population parameter, population mean. Or sometimes it may be variance, it may be proportions. So these are called parameters which we do not know. However, we have to take decisions. We have to, government have to take their decision. So what we do is we take a sample, simple sample. You see, basically, when you take sample, there are various techniques to get samples, which we don't cover here. The sample has the information, statistics. You see, we can get sample mean, as you all know, sample variance, sample pool. So these are called statistics. So basically, statistic is the one which you derive information from the sample. You cannot derive statistic from population. Statistics are derived only from the sample. That's the first thing, or the first thing you must understand, because that's a very basic thing. But most even senior statisticians, they do such mistakes. Right. So now, however, we apply decisions to populations. For example, sometimes when you do the COVID days, when the ducks are imported, they are the one called Sinopharm, they say effective 90%. That says if you apply it only 100%, it may affect to 90. So that's the idea. That is the population. They are telling to irrespective of the country, something like that. However, it has not been tested. Now, this is the sample. So, this is the population, you have population, this is unknown. So, what to do is, thus our idea is, we use sample statistics. We use the sample statistics, which we derived from the here. We can find sample mean, sample variance, to find the unknown population parameters. For decision making, we make the decision to the population on the base of the sample data. In that case, data analysis and data interpretation is very useful. You can mislead the people if you don't analyze correctly. Or sometimes you may analyze correctly, but if you don't interpret, again you may mislead. So that's a very important thing in the data analysis and interpretation. You see we get a sample and we apply for we try to derive inferences, some result, information, and apply the population. This is the main role of the decisions. Whether it is a quantitative data, qualitative data, whatever it is the procedure. You have population, you take a sample, and sample is the data, this is statistics. From here you derive statistics. You see, everything you derive from sample is statistics. And those information, statistics have a lot of information. Don't just think they are just numbers. And you spend a lot of money. They are very valuable. They are very valuable. It has a lot of information. So then the data analysis, your quantitative data analysis is a part of how to get information, how to get the proper information from these statistics. Sometimes you may do a lot of hypothesis. This is the whole role in the statistics. Now, after that, it get information, all the research, world research statistics are done by information because based on the statistic. Now, whatever you get information, then you apply to the population. You see that? Therefore, you are very careful to apply to population, very careful to get the information correctly. That source is the correct information or inferences or not derived from sample, or that is not analyzed correctly or not interpreted correctly. Application decision, population may fail. You see, if you don't get correct information, then you may not correctly apply it for the here. Ultimately. So therefore, it's not a fault of, it's a fault of, not the fault of the politicians or the secretaries. It's a fault of fault of us who make the decision. So it is due to improper use of statistics by the person who derives the information. That's the most important thing. So that is why data analysis and interpretation is very useful, very important. Now, how do we normally get data generated or data types? These are very basic things. I don't want to go more details. So these are the normally statistics. There are two types, quantitative and qualitative data. Basically, qualitative data, you can have a nominal and ordinal as a count. Ordinal means where data can be ranked. As you know, for example, gender is a nominal variable. Sex, male and female, cannot be ranked. Ordinal means very good, you see, it can be ranked. Then the qualitative data, discrete and continuous. Gender discrete means numbers for number of vehicle pass at a junction. Continuous means basically measurement. So these are the basic data. Right. So quantitative data have two types, basically two types of analysis. One, we can have a descriptive analysis, we can have inference analysis. The inference analysis is the most important, that's called science of quantitative analysis. It's a process of making estimate or prediction. All these are done by using inferential statistics. Descriptive statistics are not inferential. Sometimes we call they are very subjective. Before I go further, is it clear, everybody? Am I speaking fast? Hello? Just silence. Right. So this is called, that is the beauty of statistic display, which is different from others. We call only statisticians will claim this way. So the statistical tools are used in qualitative data analysis in almost all fields to validate our conclusions scientifically. I will consider three examples. One is very basic statistic one, other one is hypothesis testing, other one is simple modeling. I'll try to finish within the 1 hour, right? So basic statistics and interpretation. Now suppose we have a blood pressure, we get some samples for 40 from a particular village, and suppose we got the value. These are no all everybody, as you all know, you get the base statistic, minimum, maximum, all these things, and you can get it. Sample mean. So now I will see how it is useful to interpretation. Now then, first of all, this is the, when you get sample mean. Now people say the blood pressure of a man between 40 and 50 in a particular village is 151. So when you tell that one, the statement, sometimes it may be mislead. Everybody will believe all the people in this village, their blood pressure is 151. In the students or in the other statistician, these are called sample mean. Sample mean does not equal to population mean. That's the first thing. Almost most people do mistakes. This is a sample mean. This is estimator. You see, this estimator is 151. But if you take another sample of sample size 40, it may be 161. If you take another sample with 40, it may be 121. So you see the sample mean, it's a very misleading. Very carefully think. Now, for example, if I take very simple, I always teach this one. Say a mean. It's a mean is a misleading one. It has no meaning at all sometimes. If you get the mean of 0 and 100, 50. Mean of 50 and 50, 50. Mean of 60 and 40, 50. So suppose there are 3 teachers and each teacher has 2 students. They got the marks. But the dean wants only the average. So get 50, 50, 50. Then he will realize all 3 teachers are good. You see the mean can mislead. So now we'll see how people will interpret. Now, for simple example, you can say mean high blood pressure of the men in this sample is 100. That's a simple thing, very simple. But you are very careful. This is how most papers, the newspapers, they inform, how they publish it. But that value, you have to be very careful. Sometimes you can say blood pressure of the mean men in that village varies between minimum value and maximum with the mean 150. It gives some idea. It varies 120. But again, you must make sure this 120 and 170 can also vary depending on sample. For another sample, this can be varied. So again, this has not a good meaning. This also have not a good meaning. If you want, you can sometimes people use standard blood pressure of the mean in the village at village varies between this much and this much with the mean of this much and standard deviation. Again, this has no meaning. Sometimes if you say standard deviation low, you say this can be a very low, but that's the only thing, but it doesn't give any good idea. Now last one, I say, from my experience, I consider none of the above is useful to the client. If you are a good person, good thinker, it has no. Why? Because all those results, you see, all those mean, variance, standard deviation, all can vary with the sample. They are called subjective. So then how do you avoid subjectivity? Method 4. I would claim mean blood pressure of is 150 with standard error of this much. Because I got the this standard error, I got one. All these can be get from the SPSS. Right. So what does it mean? Here I don't do theory, because from the theory, when this is there, you can calculate standard confidence intervals. roughly in theory, if I recall you, in theory it says x bar plus or minus 1.96, so t value, but 1.96 roughly you can get 2. So therefore, once you give this statement, the reader can get the idea. 1.5 plus or minus 2 into this much. Normally, I think if you are all are familiar, for anyone, confidence interval is given by always estimator plus or minus table value t statistic or normal into standard error of the estimator. This is a very useful statistic in very useful formula in statistics for almost all things. Estimator plus or minus t. So based on that, I calculated 2 plus. This is so therefore it's range. It's called 95% confidence. What does it mean? What does it mean? It tells you it can be concluded with 95% confidence. You see that the population or mean of the high blood pressure of the men in that village vary this much. That's a very strong statement. And this is not subjectivity, about subject. That shows. I don't mind if you, I don't mind, I tell to client, I don't mind if you want. If you don't believe me, you go and take another samples. If you take 100 samples, I am sure 95 of the mean values vary in this range. You see that? We give a range. That's called a confidence interval. It's a very strong statement claimed by statistician. No other professional claims such confidence. So you can see how confident. The important thing is this is the idea, interpretation. You see, it can be with 95 because always statisticians we don't claim 100%. We don't want to get ourselves caught. So 5% can be an error. So we give it 95% confidence. Even if no doctor will guarantee it will be recover. They don't tell anything. If you are not failed, please come again. No guarantee. Only statistician will guarantee their result at least 95%. So you see how data interpretation. Now this is true for any estimator, your proportions, variance, any information when you give control interval is very important than the point estimator. This is another common mistake which is useful in statistics interpretation. Now most of the statisticians, most of the students, they do surveys. The common thing is they say, I will take Likert scale, 5. Strongly agree, disagree, neutral, disagree. 1, 2, for example, even our feedback, we get all these. So suppose you put a sample of 1, this is the range, this is the value. These are percentages. But when you say neutral, normally when you get how many people are don't agree, what percentage don't agree, this is wrong figure. Because 333 are neutral. So we don't know whether they are disagree or they agree or they just bluff neutral. So whenever you analyze, you must ignore that one. This is good for get information. At least you can tell out of this much. That means 19%, or that means out of this month 333, that is 90% are not aware. Neutral, they are silent, right? So you see the values totally different. If you say the percentages strongly agree, so percentages strongly agree 6.9 here 8.5. You see, if you give this information, you are again your own information to the client. And if you sometimes you give scores 1, 2, 3, 4, 5, 6, and you get a mean, you can see the means. The mean also not good because the mean is 2.4, whereas the other one we got 2.2. See the difference. Correct? So always when you have such a thing, you must clearly don't analyze this one, just ignore that. It is good for as an initial presentation, so give histogram, something like that. But when you interpret, when you are how many people are strongly disagree, how many people are strongly agree, you must avoid, ignore those numbers. Right. This is the mean score. And again, most another thing is when you have a Likert scale, don't use the variance for ordinal data. Right? Neutral cases should be ignored for correct statistical analysis and interpretation. So earlier it was 2.4 mean. Now if I say one example, if I say 5, 5 and 3, average is 13 and divided by 3, but 4 point. If we go 3, 5, 5, average is 5. You see the big difference. 5 is a good one. So therefore we are very careful when you do this. Then I'll do, I do a little bit fast, concept hypothesis testing and interpretation. Again, hypothesis testing, you can recall statistical inferences are a science of drawing conclusions about population, as I just mentioned in the beginning, based on sample information. So hypothesis testing is one of the most thing, almost all the researchers have hypotheses. You in your research, your hypothesis, you are trying to test it. That's called hypothesis. So once you do it, it is applied for the population, not for sample, right? To design something, it should be applied. For example, people recommend yield. Sorry, people recommend fertilizer. So they do experiment in sample. After that, they apply fertilizer irrespective of the area, irrespective of the whole for the population. Fertilizer for coconut, fertilizer for tea is same for everywhere. So that is the population. So indirectly, you want to test something for population. However, you do it based on sample. So hypothesis is something you just so on a population. Our testing is that take a random sample. Well, the sampling is a very difficult, very important thing in statistic. At the moment I say random for population and try to validate your assumption from hypothesis. So for one example is, for example, drug company may say their drugs is effective 0.9. Effective rate is greater than 90. So it is here. We call less than 9. Sometimes people say if you apply inorganic fertilizer, mean yield inorganic is higher than the yield organic. Opposite. So once you have hypothesis, there should be other one, opposite one. We call null hypothesis and the alternative. You see, here greater than or equal 9, less than 0.9. Here greater than or equal to the inorganic yield is higher than or equal to organic. Opposite one is this one. So we have tested. How do you test this? This is the very basic concept. Again, in hypothesis testing, we call normally H0 and H1. For example, say weight of packet of milk is 450. That is the company says. That's called H0. So somebody want to check it. Here is the false. There are some here H0 is false. So how do you take it? You take a sample. Your decision is based on the data or facts of sample. So you can take a decision, either you accept this one or reject, that's all. because we don't go to more than 2. Either you accept or reject. So in that case, you see the hypothesis can have 2 options. Decision can have 2. Therefore, as a result, you can have 4 options. This is called the probability rejecting net node. When net node is true, you see. Yeah, you reject net node when it false. So both are correct decision. Only there can be a true incorrect decision. It's like when you go to the sorry, when you go to supermarket, sometimes you may reject good quality. Even expired date is not valid, you may reject. That's the one thing. Same time, when you go to supermarket, you may take expiry date. You see, it is not correct, but you accept it. So when you go home, sometimes your wife or mother will scold you. Why did you bring the expiry? See, these are some mistakes can happen. 2 common mistakes. But so in the hypothesis testing, we try to minimize those two incorrect decisions and get the correct minimize this one and try to do hypothesis testing. Generally, what we do is, and again from these two, we try to keep one constant. Here we keep probably rejecting net node. When net node is true, we assume 5%. That means again, 5% is the how, if you ask how 5% come to the scene, generally, this is the, value after discussing with the clients and statistician, that is the compromised value 5%. Sometimes it can be go to 10%, 1%. In the exams, you can ask questions can be asked different way, but generally we take 5% is the standard value. So I'll see one simple example very quickly. Now we see a company manufactures bulbs with mean lifetime 120, and they, due to market expansion, new production method has been introduced. So their company president want to know whether is there overall change in the lifetime of the bulbs. What does it mean? That shows. Now, then suppose there's an engineer. How does the mechanical engineer convince the vice president? So he has to convince. So in that case, he has to take a sample. For example, like if I quickly grab this one to you, you see, there is a population here. We assume the population has a mu. Yeah, parameter is the lifetime, random variable is lifetime. So we theoretically we assume as to familiar distributed normal with mu and sigma square. So now we won't test this mu. So we take a sample. That is the mechanical engineer should do it and test. So you can sample mean if you say 205 or 205. Obviously 205 is greater than 200. Even 2.1 is also greater than 200. Correct? And yes, you see that? And 201 is greater than 200. So you have to be very careful. What is the value that is one we call hypothesis testing. This is the very subjective value. To do that, what we do is, as to know the theory, we don't do it. This is the way. So therefore, after that, you need to construct your hypothesis. So our thing here is mu is 200. Mu equal to 200. Now mu equal to 200 means this is another mistake most of the students and the lecturers do. Population mean is equal to 100. This is not true. This is totally wrong. This is wrong. You can't say population mean equal to sample mean. This says is again not equal mean. Don't say population mean is not equal to 200. That's also wrong. This 200 comes, you see, the engineer thought he took a sample of 50, right? 50 numbers are there, and you have 50 numbers, and you got the mean this much. So by looking that, 203.5 is greater than 200. 203.5 is greater than 200. So without any test it, he can say, oh, well, it has changed. This is because this is not 200. I mean, can be done in anything. You don't need statisticians. But statistician, your base, whether this value is significantly different from 200. The significant word, I will, if I explain, sorry. The significant word is a very tricky thing, only statistician knows with confidence. Be careful. So anybody can use significant. For example, if A, suppose there are two persons, A and B, if A is doing, say, 200,000 per month, if B is doing 250,000 or 210,000, B can tell, or A can tell, B is doing significantly higher than me. But B may say, I'm not getting significantly lower, higher than A. So that word is very subjective. That significant word is misused by many people, many ways. In statistician, significant is used only if you test in a proper way. So this mean, you say population mean is significantly different from 200. In other words, we are identifying what is the values. This is the mean sample is 200. It's a concept of confidence interval. So we can have what is the range? It can vary. This is the range, it can be 95%. If your mean value, what took a sample, it belongs to there, it may be, I just give here 95, I say 205. Then you can claim there is no significant difference. This one. If you get something here or here, we can claim it is significantly different. So the theory is here. Sorry. You see, these are the important thing. These are called two-sided. So then I think that under statistics, you get the t-values, all statistics. This is the p-value. But normally you are telling the p-value is less than 0.5. This is 5% mean 0.05. You accept H dot, otherwise you reject H dot. So you see, as p-value is greater than 5%, we do not reject H dot. And sometimes, what does it mean? You see, again, it can be concluded with, this is how interpretation, with 95% confidence that the lifetime of bulb produced under new management is not significantly different from 200. Indirectly, it says the new management and the old management has not significant differences with respect to the producing bulb. Another, it can be 95% interval. The two management are not significantly different with respect to lifetime of the bulbs. In the same management, the whole thing. That is how you interpret. Now again, if I go back here, once you accept to reject, this is another common mistake most even postgraduate student, undergraduate student do. And textbooks also they say there is not sufficient data to accept. That's totally wrong. You can't claim no sufficient data. The reason is you are the person who collect data at a proper way. Once you collect data, you can't claim data is not sufficient, data is not proper. That's totally wrong. You must tell confidently conclusion. Don't tell data is not sufficient. You see, it can be concluded with the other way, if not. That's the important thing. That is the yeah. I have another 15 minutes. That is how we do it. Right. Then I'll go to the last one. I have only 15 more minutes. The modeling. That's another important thing. Very important in most. So what is modeling? Modeling is a very simple nowadays. Everybody take modeling. All data scientists, big data, model. It's a very common. I made model on modeling. In the modeling, what you always try to explain, you see, if there's some one variable, say your temperature can vary. How do we explain? So basically, explain variable observed equal response variable. You see another variable. You see, this is this one. Say this variable. Suppose you observe one data, say with the experience, people experience salary, whether they are, whether irrespective of their service, they get same salary. So there's no variation, nothing to explain. Simple. So you don't want to model. Anybody can say whether you have experience in 1 year or 20 years, you can salary about this example. This is another example. See, statistics mark and psychology mark. Example, very nice graph. You see, there's straight line. So it's simple, it's very easy to model. You see, there basically, you can say as long as you get this equation can be done very simply. It's a simple straight line, you can easily predict. So basically, in this case, now in the previous case, nothing to no external variable is simple straight line. In this case, we are trying to explain the marks of physiology marks using statistic marks. Then the y-axis is a response variable is called independent or explanatory variable, where we try to explain the response variable. Look at that one. Selling price and assessing price. Sometime in the what do you call this? The people who sell the houses, they assess first and selling price. So the company won't know whether his assessed price is correct or not. Because if example not correct, there's some fluctuation. In that case, you have a model. You see, there's variability. Now, if you look at the previous case, no variable at all. So nothing model. Modeling is done for the explain the variability. Here, no variability. Here, there is variability, but variability can easily explained. But this you cannot. So concept modeling is basically we have observed data. We try to fit a model. However, you see, as I mentioned here, even here, once you fit a model, there are errors. So our concept is observed data model. This is the whether you do any type of modeling, right? This is the concept. No matter whether simple model or regression model, any model, this is the same concept. So this model is your problem is identify the model. Now in this today, the data representation, I consider simple linear model. Because if you look at here, in that case, once you put the data, you can see there is an increase in trend. So I can fit a straight line. So in that case, this is the model. So the concept of modeling is this one. So therefore, once you have a concept, then your problem will become to estimate these values. Again, these values are called the parameters. After that, we estimate from a sample, they are called estimate. Then I think if you recall, if you know theories, sometimes we call beta naught hat and beta 1 hat. These are called parameters. These are called estimates. You see, because we do a sample, but after that it will be true for all. Thus, our problem simple linear model is to estimate two parameters. So basically, what is model has a variability. Indirectly, we are trying to explain the variability by a model. Model also has a variability. Now, if you look at here in this case, this is a model. The model also has variability. These are model points, they are not equal. In the previous case, no variability, either model or the data has no variability. Right? So basically what to do is, therefore, we try to observe the model variability plus the model. Right? If there is no variability, observed variability or model variability. So that basically your life is very simple, no problem. But the problem is you try to observe variability, takes the model variability plus the error variability. So if it is a very good model, error will be very small. This observed variability should be, or in other words, model variability should capture more of the observed variability. That is why you have the R square. I think you are very all familiar. The ratio between the model variability and the observed is called R square. That tell how, what percentage of variability has been explained by the model. That the value. Generally, it is most people want to fit a model. For example, in this case, in this data set, if I quickly show you SPSS squared. Now, this is the data set quickly, SPSS. That one is. These are two data set. I think you all can analyze, good analyze, and the regression, linear. Your response variable is selling price, ESS price. And if I don't do any of these, if I press OK, you see the model is coming here, right? Because the R square, this is much higher. Correct? That is what I have shown here. So when you come R square is very high, oh, you are very happy. But don't stop at this stage. There are many things you have to test it. Otherwise, your model is not accepted. Right? If you get here, observed variability, model variability plus error variability. If we call errors are random, that means errors cannot have a pattern, systematic pattern. If the errors can have systematic pattern, whether your R square is 95 or 98, it is wrong. Suppose your errors are like that. One plot. Suppose your errors are something like that. Or less, something like that. That shows you are not captured the model correctly. That is why we call errors should be random. That means no systematic pattern. Right. So this is that shows model explain 92% of the observed data. And if it is a simple model, models are significant and the parameters can. So this is the equation you all can take. Right? This is what I show in the this is the model. So model can easily explain. Basically, as you all know, it's very simple. I mean, since you all are familiar, it's a simple linear equation, like algebraic equation. If you have a plus bx, and again, don't say a is the intercept, b is the gradient. That's totally wrong in the statistics. You have to interpret correctly. A is the value where what is the value of y when x equals 0. B is the amount of increase, so about if you increase by x 1 unit, how much increase by y? I think simply the idea is coming from here, y equal x. Suppose there's a y1 equal a plus, if we increase by xy unit, x1 plus. One equation, two equation. If you subtract 2 minus 1, you will derive different y minus y2 equal b simply, right? I think this is the basic idea. Those who know basic mathematics can understand. Other thing is sometimes more statistic is very easy to understand if you know the mathematics. So then only we can explain clearly, interpret. Otherwise, the student asks question, we say, oh no, don't ask question. But this is how B value coming. You see, if you increase by 1 unit, so here it says a unit increase of assessing price, selling price will increase by this much. However, you see, my warning is, it is still not sufficient to recommend the model forecasting. If you go and tell to the company, say, the company president, I fit a good model, my R square is much, 99%, 98%, I don't think the president won't give you increment. Right? He won't satisfy it. Yet he will ask, what is the error you made? So if you say 99, you can say error 1, that's wrong. There are many things to be done. First of all, you must make sure in the modeling there are various concepts. Randomization, error should be random. That's most important thing. Novelties can be as a third. Don't worry about novelty. First is important is randomness. Otherwise, constant variance, that's errors. If you remember those who have, sometimes there may be students who have done statistics, so you remember we explained IID, normal, 0, sigma square. First is, this is the most important, I would say 4 stars here. This will be a 3 stars. Normality is the second thing. If it is normal, there are various methods. Correct, you must make sure randomness. Now, even of all these randomness, then I think most of the people use the root MS square, M mean square, and say this is my model has, this is very low. I don't believe these things. It's not totally correct. I mean, for the planning point of view, the present company president point of view, he'll ask, what is the percentage error you do mistakes? Sometimes you may have good, for example, you may nice, for example, you may something like that, you see. But there one point here, correct? So these are things you must, there are various methods where if there are such a thing can be in the modeler has a lot of freedom. Sometimes these points can be ignored with justification, not just right? There are methods. So normally what I advise all students, you must calculate the percentage error. If you don't calculate percentage error, I don't believe your model. Whether you have a minimum, sometimes people use compare AIC, BIC statistics, those who are familiar, you see. Even the assumptions are satisfied, overfitting can thus. Percentage error is a more important from a client point of view, as it gives a good picture about the percentage deviation. Right. So there are, as you know, test of some randomness normally can be done in DW statistic, or beta is autocorrelation. DW statistic measure only first autocorrelation. Sometimes you have a series of errors. DW statistic tells only the first leg. If those who are familiar with the autocorrelations, if you autocorrelation like that, this is the, see, oh, sorry. You can have first one is not significant, others, one can be significant. So therefore, best thing is to deal with the disease, okay, autocorrelation. Constant variance, You can plot the residual and the predicted values and normality. If I quickly, I think my time is finished. Yeah, okay. If I quickly show you how in the SPSS, how we done. It'll take only 2 minutes. This is the data file. Yes, they already opened it. Yeah. Sorry, this is the data file. All right. How you test this one is you go to the analyze and distribute the statistics. Sorry, the regression, lead regression. You do this one, and you must make sure you go to the save. You can save the understand and residuals. And the other predicted values are here, or in the predicted values, understand and predict. Always get the understand race. You say continue. It's okay. And you can go back to SPSS. You have residuals or residuals. So the percentage error is the important thing. You go to the analyze, you transform compute variable. I calculate percentage error percent. Right? It's a residuals. Error percentage is the residuals. Residuals into 100 into 100 divide by the observed data, your assessed price, sell price. This is important. You see, yeah, this is the, you can see these values. It can vary from minus to plus, minus to plus. You can see there's one point where highest percentage is 7.